All right, so this is going to be our lecture on subsystems. So, what is a subsystem? It's a way to separate the robot into parts and control it more efficiently. It makes debugging the robot easier and makes the code more readable. You can make a subsystem responsible only for its parts, and there's a clear thing to do in each class. And what is the format? It should always have a hardware map as a parameter. And essentially, what this does is it allows us to initialize everything in house or in class. So nothing has to be done outside of the class. Um, and you'll see when we get further into it what actually happens with that. But we'll have the init method, which will initialize the subsystem, our update method, which will update subsystem components, and telemetry, which will show us the feedback. So what we're going to do is go through the process. So our first step is to create a new class named blank subsystem, like for instance, ARM subsystem. And then we're just going to hit this button, which will implement the methods for us. This is using the subsystem that is in the gentrified apps util library. However, you can do it without that by just taking out the extend subsystem. There's a lot of different ways to do this. This way will just give you all of the different methods immediately. So what then that will look like is this, where we have our init method, we have our update method, and we have our telemetry method. Next, what we can do is we know that there's no constructor. So we hit this create constructor matching super button. And what's that going to do? It's going to generate us a constructor. So what this constructor will do is it will initialize our subsystem, which doesn't do anything. So this is really just not that useful. It just makes sure we have the proper things in our parameter list for the subsystem. But what it looks like then is going to look like this. And we'll have our hardware map defined as a variable right here. And we'll just say, hey, our map is equal to hardware map, which is passed in right here. And then we'll call the init method. So what this is going to do is it's automatically going to assign this map variable at the very top to the hardware map we passed in. Then we can expand this further and we can say map.get, and we can do the normal process to get each motor just with map instead of hardware map. And the way this works is we take our hardware map from our teleop and we pass it into the subsystem, which then passes it into map, which then we can use in init right here, and we can get the motor. So the init method, initialize every single one of the devices, set the values you want to set when you press the init button on the driver station, other initialization steps like scanning April tags or just basic autonomous vision tasks. And then for the update method, we should only place this when we're updating our motor power or servo position. So essentially, if you're updating your motor position in a bunch of different places, it's going to set it to 0 and then set it to 1, and it's just kind of glitch out and like go everywhere. However, make sure you set it once at the very bottom of your update method. You'll also, this is basically where your main loop is going to be for your subsystem. So like setting motors and taking gamepad input and like all that kind of stuff is going to be in this function. The telemetry is the driver station feedback. This is the only place you're going to put telemetry. If you put it in other places, it gets a little bit more confusing. Also, make sure not to include telemetry.update. You should include that at the very bottom of your teleop. But in this specific case, we basically just want to populate our telemetry. That's all we want to do. We just want to get it all ready and then send it. So then we'll move into a demo. So this is one of the subsystem-based controllers that I had. Essentially, each one of those movements was a singular like button press, basically. So this was an auto, so we can use our subsystems, like we had a drive subsystem, which is down here, and then an arm subsystem, and then a claw subsystem. And basically the way we designated that was to make sure that each part of the robot was separated. So nothing relied on anything else, and everything else didn't rely on one thing. So then, yeah, so you can see a larger breakdown of what we had. We had our scoring subsystem, which was that claw subsystem, and then our arm subsystem, and our driver aid, which was another kind of subsystem, but really it just made it easy for us to hit one button and it does basically that whole process all in one. And then drive subsystem is that base part. Localizer subsystem was just a Roadrunner wrapper. So for an example drive subsystem, we'll take our front left, front right, back left, back right motors, our hardware map, our auto, Boolean, and then our op mode. This is one other thing I forgot to mention. It's usually nice to take an op mode as well as input because it allows you to use telemetry in house, and it doesn't force you to do anything weirdly. You can also do gamepads in house using this method. Then we'll define our constructor right here and essentially just assign our three variables. That's all it does. The constructor just makes sure the class is constructed correctly. And then we have finally our init, which will call the next method I'll show you. So for that init method, what we're going to do is we're basically just going to get our four motors, set them all to be braking, and if it's auto, we want to stop and reset all of our encoders. So this is the reason we include the is auto Boolean, because we can actually control things separately in our init method, whether it's auto or not auto. So that's one of the things that I like to do is it makes it super easy to be like, oh, in auto we need to do this, but in teleop we need to do something completely different. So let's just do that. But then for our update method, in this stance right here, I'm using my gentrified apps util library just to make it more concise so we can actually see what's going on. But in our update method, we're just going to take our op mode dot gamepad1. That's another thing. Op mode was defined as our variable as linear op mode. Back up at the very top where our variables are. So now this will reference our op mode. So what we can do there is inside of our teleop, right? We can just say this when we're passing it into the parameter list. So like it would be like arm subsystem with hardware map true, and then this, right? Where this is going to refer to our teleop. Or this will refer to our auto that we are currently in. So that allows us to use the op mode to refer to the gamepads, to refer to the gamepads again, all that kind of stuff. And yes, I know this says gamepad 2, but then we set the power at the very end, and that's all we need to do. So for the next step, we'll have our telemetry method where we take our telemetry as a parameter, and we're just going to use that all the way down the line. And we're just going to add the data. For this, I just wanted it to give me the power outputs just so I could see it. So some subsystem tips. You're going to learn a lot of different methods of the control that you want to have on your robot, right? Like hardware classes, subsystems, all that kind of stuff. So it's really important to go with what you learn. And we'll go through a little bit of how you can use this in parallel to hardware classes. But make sure subsystems are confined to be at most about 4 actuators. And obviously, that's not a hard limit. Go with what it needs to be. However, it gets very complicated very fast. So make sure you are limiting it as much as possible. Make your subsystems pretty specific. The main problem I've seen with the subsystem method is people have it encapsulate half of their robot, and then the point the entire point of making it a subsystem is now gone. And if you need an op mode to be passed in as a parameter, don't be afraid to add it. Um, this method should be fairly easy if you do it right. If you don't do it right, you're going to have a bunch of references darting around and it's going to get complicated. And we don't want that to happen because then it makes it terribly difficult to debug. So there we have it. I hope this was useful. And thank you for watching.